Welcome. We're going to look at how boundary conditions are represented in free body diagrams. So hopefully this will be short and sweet. What we got is a beam here, and I can take this beam right now, I can move it back and forth like here. There's just no problem in doing so. I can move it up and down. There's nothing keeping it from moving up and down, nor is there anything from restricting its rotation. Those are the three kinds of things that we need to be concerned with when we're looking at boundary conditions. So if I bring in over here now this support, then the here we go, pin, right? It cannot move in this direction either way. It cannot move up and down at this location right here. This is the only thing we're worried about, is what's happening over here on the left hand end. So when I draw a free body, but it's free to rotate around that pin, so it's kind of hard to do here, but because I want to do this there, it's free to rotate around that pin. So if it's free to do that, then when I come to my free body diagram, what are my restrictions here? The motion is restricted from going up and down, so I'm going to have a force. I can put it on either up or down, and I can put on a force here going to the left or to the right. It doesn't matter, because the equilibrium part of this will work out as to which direction it is actually going. So now if I bring in this roller here, then what does it do? So I'm going to take and move that stuff over here. Now ask yourself, at this location, what will be the motion that is restrained? It cannot move up and down. And in this case, supposedly, it can only be a force that moves upward on that beam, because there's nothing above it to hold it down. So it would have to be going in this direction. But it's free to move left and right. It doesn't matter what the constraint is over here on the left. You ignore all those constraints, and this can only provide resistance to movement downward, and it's free to rotate. So my free body diagram would have these three forces acting on it, and that would be it. So we have a little bit more difficult problem. I've got this mechanism here where this will move along a track back and forth, and then we want to look at the details here of what are the forces that are acting on this piece here. Well, let me go put it back, because note, it's not touching at the top. So the only thing that I can have here is, if it's only touching at the top, on the bottom, then I'm going to have a force here, and I'm going to have a force here. And then I have in return then the equivalent forces that are going to be here like this. We call that A and B. A and B. And then they cannot switch signs. This is all from the boundary conditions. It has nothing to do with what the loads applied are. It's only boundary conditions. So that's one of the things that we really worry about, is in looking at boundary conditions, if I remember right, is we've got to see what is restricted and what is free to move. So now I've got a cantilever beam. And when you have a cantilever beam, it's not free to move up and down. It's fixed at the left-hand end. So what does that mean? Well, that means then I'm going to have a force that's going to be either up or down, it doesn't matter. And it also keeps it from moving in and out, so it can't move in that direction. So that means then I've got a force that goes either to the left or the right. These are all just due to the fact of the boundary, the junctions, if you will. So when I also look at this, you know, this thing cannot rotate right down here locally, or the whole thing can't rotate. Can't do that. And so it fixes it from rotation, which means I have to have a moment. That wall provides a moment that's, for instance, like that. So that would be my M. That could be my AX, AY, duh. And my AX. And I don't have any other constraints on this beam, so that would be it. Now, putting on the whatever loads are applied, then we can do Newton's laws and figure out what those two forces and the moment are. So, when you go look at something new, you have to say, is there a force or moment present? And you need to check to see how the motion is restrained. It doesn't mean it stops it completely, but it restrains it from moving. You can think of it like a spring or something like that. Is it constrained from moving or not? And in these 2D problems, it's, you know, if you will, in the X and the Y direction and the rotation. So hopefully this will be helpful when you start looking at more complicated situations. And I'll have another one on free-body diagrams that has to do with joints, in particular pins, and how do you handle those.